Rathi, am I audible? Khatani.
Yes, sir.
Khatani. There is a Pushkar Bagde, Gadmal. Okay. Here now, all the following substances classified into three groups, like this with the help of litmus, lemon, tamarind, baking soda, buttermilk, vinegar, orange milk, lime, tomato milk of magnesia, water. So how we can write it? How we can separate it? Can you tell me? By which method we are separating them? Can you tell? Okay, yeah, basic thing that we are going to look at it's
Classification.
classification. The classification we are doing by taste. Those having the SAR test, we are seeing that that is a acids or base SAR test. SAR test is their acidic nature, and suppose they're bitter and slippery. Those are like as a soap test. We can classify them into the base, and then remaining we are keeping in them where we can keep. Can you tell me acid, bases, and third one?
Salt.
Yeah, acid, base, and salt, we can separate them. Now here fill in the columns in the part A of the following table. Now here see HCl3, HNO3, HBr, H2SO4, H3BO3, NaOH, then NH4OH, NaCl, NO3, 2, K2SO4, CaCl2, NH4, bracket 2, SO4. Okay, so now it's name their hydrochloric acid, then we can write it H plus Cl minus acidic radical, that is the acids. Now HNO3, what is meant by HNO3? Will tell me its name. HNO3 will tell me about the HNO3. Here HNO, yeah, HBr we are going to speak. It's their hydrogen bromide, H2SO4, hydrogen sulfate. Then H3BO3 will tell me H3BO3. Anyone? Do you know about this? Answer? Just one. I think only one girl is giving the answer. Yeah. Then next one NaOH, sodium hydroxide, is very simple. Then KOH means potassium hydroxide, CaOH2, calcium hydroxide, NH4OH. What is meant by NH4OH? Who will tell me? Anyone?
Ammonium hydroxide.
Ammonium hydroxide.
Now NaCl, who is going to tell NaCl? NaCl, sodium chloride.
Sodium chloride.
Very good. Ca3 bracket raised to 2, bracket 2 will tell.
Sir, I think so.
Yeah.
Calcium. Right?
Calcium nitrate.
Calcium nitrate.
Very good. Then K2SO4.
Potassium sulfate.
Very good.
Potassium sulfate.
Potassium sulfate.
CaCl2.
Calcium chloride.
And
Calcium chloride.
NH4.
Ammonium sulfate.
Very nice. It's ammonium sulfate. So like this, we can write. And now you have to write this name here. Then it's basic radicals and acidic radicals you have to write. And then you have to find out it's acidic or basic in nature. Okay, can you do it? So you will see those having shows their H plus radicals, basic radicals. They are, or these compounds are called acidic compounds. And those show their OH minus radicals. Generally, we are speaking OH minus radicals that are called basic radicals. Okay, and basic compounds, and those are showing both H plus as well as OH minus that are called the salts. Okay, so now here we have to see complete the part B. Just means you have to complete this. Okay, and then we are going to start the ionic compounds. So what is by ionic compounds? Will tell me ionic compounds. Anyone, do you know about these ionic compounds? Already, I think yes.
Ionic compounds are the compounds that are formed by combination of ions.
Yeah. The compounds which is formed by the combination of two ions, that is the one is the cation, positive ion or basic radical, and anion, that is the negative ion or acidic radical. These compounds are called the ionic compounds. So you will see between these ionic compounds, there is a strong attraction between it, and they are due to the opposite charges. One is the positive, one is the negative. They are strongly attracted towards each other, and due to that reason, these oppositely charged, they attract towards each other and release bonds. That's bonds are called the ionic bond. Okay. The force of the attraction between one positive charge on the negative on a cation and a negative charge on the anion makes one ionic bond. See there. One positive charge and another should be their negative charge. Then it's will be say like this ionic bond. Now here we have to see this example here. Very simple. Example is given our regular example, that is the sodium and chlorine, and this is shown by their its electronic configuration. In first, how many are there? Sodium atom number 11. So due to that reason, sodium atom number is 11. So we can write its electronic configuration, that is a 281. And about the chlorine, we know that its atomic number is 17, that is a 2, 8, then 7. Okay. So what happened here? 281, 287. So in this, so its duplet is completed, then its octet is completed, and in last cell, there only one electron is remaining. Okay, that is one valence electron is present in it. And then when we are going to speak about the chlorine, it's if you see 287 means duplet is completed, plus octet is completed, but last cell there 7 electrons, and we know that it this third cell it's their capacity to complete total 18 electrons. Okay, problem means like this 2 plus 8 plus 8. So here 1 is remain. So that is a valency of this 1 and this 1. Then this 1 positive here, it can donate easily and it can accept easily. So due to that reason here positive and negative ions or charge, they attracted towards each other and they form a bond, and that bond is a ionic bond. And we are seeing that compound, that is the NaCl, means our common salt or sodium chloride. Got it, everyone? Yes or no?
Yes, sir.
Any
Yes, sir.
difficulty in it?
Yes, sir. No.
See, very simple. If you know its atomic number, then easily we can write its answer. Somebody raise hand here. Yes, anybody want to ask question? Yes, Parth. No? Okay, can I take next? Now, this depends on this electronic configuration. It's very important. Yes.
Sir, my question was that if the atom loses its one compound and gives it to another, when the that atom loses its compound, that atom gets the positive charge or negative charge.
See, it's when we are saying that compound, it's not actual word for compound, it's their word for it, that is the element or substance. That element, suppose the sodium is the element here and its atomic number is there 11. So 281. When why it can lose easily? Because in its outermost cell only one electron, it's not strongly attracted toward the nucleus, and when it losing or donating, losing means I'm saying it's losing, that time it's having their positive charge, and those are accepting, it's having their negative charge. Got it?
Okay, sir. Okay, sir. Thank you, sir.
So now here you will see, so what happened here? 281, due to that reason one electron was there, and this one electron, when it will be combined with this chlorine, its outermost cell already 7 electrons, 7 plus 1, it will become the its octet completed. Okay, so in this first also and second, then it's we are getting that salt, we are getting it salt, because there is no any one charge remain on that solution or on that compound. Na plus Cl minus we can write like this, but one plus and one minus, it's become there attracted, so it's become directly uniform. Okay, so due to that reason, there is no any one charge is present in it. So an electronic configuration with a complete octet indicates a stable state. And then this ionic bond is formed between these positive and negative charge. And due to that reason, it's highly stable or very high stability is formed in this compound. Okay. Now, when dissociation of ionic compounds, suppose you see water and salt. When we are adding salt in water, that time what happen? That salt is dissolved in the water molecule, and we can't separate it because it's totally homogeneous mixture made up. So in that, those are positive and negative charge, they are separated from each other and they totally mix up with the water molecules. Okay, means here ionic compounds, they dissolve in the water, and their opposite charge ion in the ionic compounds are sitting side by side. And this ionic compound begins to dissolve in the water, and the water molecules penetrate in between the ions of compounds and separate them from each other. And due to that reason, they are dissociating, separating, they are splitting from each other. So due to that reason, this process is called a dissociation of ionic compounds. So we can take the example another water and sugar. You are eating, no? Are you adding sugar in water? You can do after this our session, this experiment. First take the salt in water and then stir it. You'll get it. Afterwards, you will not get the salts in even the particle. About sugar also, you can take the sugar, okay, and add it and stir it. After a few minutes, you'll see that sugar is totally disappeared. It is not present here. Water and sand, even though you are going to take now water and sand, you'll try, you'll stir, then also it will be not mixed up, it will remain as it is. Then water and salt, the same thing is there. So these things are going on. Means what happens is about the salt, water and salt, water and sugar, there this salt atoms or it's whatever the molecules, they are dissociated. Means Na and Cl, they were dissociated due to that reason will not get it. Sugar also same thing. So each of the dissociated ions, the aqueous solution is surrounded by the water molecules. You can see here sodium chloride in the water. So what happened? Their bonding will be, they become weak, they will be separate from each other. And here we'll get like this. That is the aqueous solution. NaCl gives Na plus Cl minus. Okay. Got it, everyone? Yes or no? Means in ionic compound, what happen? Positive, negative charge are together. Okay. And when we dissolve in the water or like this, anyone dissolvable solution for it, then we'll get again Na plus and Cl minus separately. And both will be there in aqueous state. Okay. Got it? Yes or no?
Yes, sir.
Okay.
Yes, sir.
एसोसिएशन का मीनिंग है सेपरेट होना, अलग होना। तो हम आज के इस वीडियो में पढ़ेंगे कि जो आयोनिक कंपाउंड्स होते हैं वो कैसे सेपरेट होते हैं, कैसे अलग हो जाते हैं।
So you will see here, these are shown its compounds. Suppose it's here water and salt. So when we are going to dissolve it, NaCl means your common salt, remember, okay? Okay, this NaCl we are going to dissolve in the water and then we'll get that separated from each other. Now see, okay. You can do this experiment at home also, no problem. And what we are getting there, when a solid ion compounds begins to dissolve in water, the water molecules push themselves in between the ions. Means when this water is there and is dissolved in the water, that time it will get separated from each other. That is, we have seen, we are getting here like this, NaCl convert into the Na plus and Cl minus. Okay, and this process is called, means separation of ionic compounds from each other. That is called a dissociation. Getting it, everyone? Yes or no?
Yes, sir.
Any problem
Yes,
here?
sir.
You can take, you can do this experiment at home also. Very simple way. You go in kitchen
Yes, sir.
or ask to your mother about sugar and salt, where is that bottles she has kept or where she has kept that boxes, and from it you can take and you can do it. Okay, and everybody have to do today itself and make its video. I want that video. Okay, because I am going to share.
Yes, sir. I will send it on WhatsApp.
Yeah, WhatsApp. You have to send everybody that videos on my personal WhatsApp. About Arrhenius was an Swedish scientist, Arrhenius, and he has given the one theory about acids and bases in 1887. So in this theory, what he has given that an acid is the substance which, on dissolving in water, gives rise H plus ions. Only cation. He has decided. He has made that assumption when these acids are dissolving in the water, that time it gives only H plus ions, and then we can say the substance which dissolve in the water and which give the H plus ions, that's called the acid. For example, he has given HCl, H2SO4, HC, H2CO3, HCl means hydrochloride is dissolved in the water, it dissociated in H plus ion, aqueous and Cl minus. H2SO4 is liquid. When it's dissolved in the water, we'll get H plus and HSO4 minus. Then HSO4 minus there, it dissociated, we'll get H plus and SO4. So, okay, so this he has given the assumption about the acid, means he has given the statement. See about the base. What he has given, same thing he has mentioned. The base is the substance which is on dissolving in the water, which gives OH minus ions. That's called the only anion, and it's called the base. So he has given us some example. NaOH means sodium hydroxide. When it reacts with the water, it separates the Na plus and OH minus. Then calcium hydroxide, you could see it will be dissolved in the water. We'll get the calcium and hydroxide separately. Okay, so he has given the theory on that RNA theory. He has given like the statement for the acid, the substance which dissolve in the water, which give the only H plus ions, that's called the acids, and the substance which dissolve in the water, which gives only OH minus ions, that's called the bases or anion. Got it, everyone? Yes or no?
Yes, sir.
Now, this classification of acids and bases, so strong and weak acids, bases and alkali. So just we have seen RNA's theory, who has given this in 1887 about the acids and bases. Now, which substances we can say the strong acids, which substances we can say the weak acids, strong base and weak base. Already so many substances we are using at our home, that also we can identify. Okay, now which are that? So on dissolving in the water, strong acid dissociates almost completely and resulting aqueous solution contains mainly H plus ions. Those substances use only H plus ions, that is acidic radicals, that's called the strong acid, like this suppose HCl, HBr, HNO3, H2SO4, some examples are there. Okay, so weak acids means on dissolving in the water, these substances, it does not dissociate completely, means they does not dissociate directly H plus ions only. So it will show there is a aqueous solution of the H plus and it's constant acidic radical in small proportion. Means here what happened? It's acidic, but this H plus ion is present in the small proportion. And in this first, you will see they are strong. Their H plus ion is there in strong, means I want to say here that is in large proportion. Okay, here less proportion and here large proportion. So it can say the strong acid and it can say the weak acid. So examples are there: CH3COH, CH3C-OOH, that is the uracetic acid, carbon dioxide. These are the weak acids. Yeah, Parth, do you have any question, madam?
Sir, please explain against strong acid and weak acid. Not
Okay.
understood clearly.
Okay. Once again, I will explain it. When this substance dissolves in the water and it will be dissociate completely, means suppose we have taken the ACl this solution and it will be completely dissolved in the water and it gives us strong, large proportion H plus ions. Okay, mainly contain their H plus ions. So that's called the strong acids. We can take the HBr means hydrogen bromide, there also will get. So what is their strong? That is the H plus. Okay, our main constituent should be there H plus, that's called a strong acid. And weak acids, it's not completely dissociate. Given the example CH3COOH, where it will be dissolved in the water, that time it will not completely dissociates or will not get their main constituent H plus ions. Will get their H plus, but it will be there less its proportion. So due to that reason. It's called the weak acids. Okay, understood? Means what happens, these H plus ions, it will be dissociated less, and undissociated H plus ions is the more in these weak acids. Now got it? Yes or no, Parth?
Yes, sir.
Okay.
Yes, sir.
Now we have to see their strong base. What is meant by strong base? On dissolving, the strong base dissociate almost completely and resulting aqueous solution contains OH minus. Means what happen? Whatever substance we have added in it, that all substance will be almost completely dissolved. It will be dissolved, and its main constituent of that solution will be 0 OH minus. That's called the strong base. So here you can see sodium hydroxide, potassium hydroxide, calcium hydroxide, sodium oxide. Okay. Now we can take the weak base. It is not completely dissolved in the water or dissociate their OH minus ions, and it's called the weak base. And examples are their ammonia. Example is ammonia. And last one, alkali. The bases which are highly soluble in water are called alkali. Those bases like as a NaOH, KOH, NH3, those are highly soluble, means they most dissolve in the water. That's called the alkali. And these NaOH, KOH, NH3, NaOH, KOH are strong bases, while the NH3 is the weak base. So those bases are completely dissolved, highly soluble means they completely dissolve in the water. It's called the alkali. Okay, getting it? Yes or no? समजते का
Yes, sir.
हे अडचण आहे?
Yes.
No, sir.
हां. So
No, sir.
basicity and acidity we have to see. Can you tell me what is meant by acidity? Actually, we have listened so many times this acidity word. Will tell.
Yes, sir.
Yeah, will tell me about the acidity. Acidity means what happen in our body. H plus ions in just we are seeing that acidic, sour taste. Okay. If those person having their problem due to their so many reasons, acidity due to the you'll not sleep early, then also you can face the problem of this acidity. About I am body speaking these things. Okay, our human body. And about this basicity and acidity, just we have to see where is the H plus ion is strong. H plus ion, number of H plus obtained from one molecule, that we have to find here. H plus here H plus in this H plus, but here H plus, here H plus. But how many that you have to find out in base number of OH minus obtained from one molecule, you have to complete this chart. So first H plus one ion, you will get the second one. Third in H2SO4 you will get there 2, H2CO3 you will get there 2, H3 there 3, H3 again 3, CH3. Now here you will get the H. Okay. So about this NaOH, OH minus 1 in the sodium hydroxide, KOH, there just you will get 1 OH minus ion, then OH2, there you will get there 2 OH minus ions, then OH2 again same thing. So like this you can complete this acidity and basicity. So basicity, the number of H plus ions obtained by the dissociation of one molecule of an acid is called its basicity. What is meant by the basicity? See, number of H plus ions obtained by dissociation of one molecule of acid. Okay, when we'll get to obtaining H plus ion, dissociation of molecules of an acid, it's called its basicity. And the number of OH minus ions obtained by the dissociation of one molecule of base, it's called acidity. Got it? Acidity of bases. These definitions are very important. Remember this. Just see the words. The number of H plus ions obtained by the dissociation of one molecule of acid, it's called basicity. It's basicity. And OH minus obtained by dissociation of base, it's called its acidity. Got it? Or any problem here?
No, problem is not there. Got it, sir.
Understood everyone?
Yes, sir.